Welcome to this Wise Owl tutorial on sets in Python, presented by our very own guest speaker, Annie the cat. She's been mentioned often enough so far, I thought you might like to see her. Here's what you'll cover in the tutorial. So firstly, we'll have a look at what sets are and how they can be used in Python. Then we'll take a brief digression to look at a very small amount of theory on sets, less than a minute or two, I promise. We'll then look at how you can create sets in Python, before going on to look at some set operations, like getting the intersection and union of two sets. We'll then look at some examples of sets. Firstly, how to remove duplicates from a list shopping list. Secondly, how to count the number of unique letters and words in a string of text. And thirdly, we'll look at how to compare two lists to see which Premier League teams were relegated and promoted in successive seasons. At the top right of the screen, a link will appear about now, and you can click on that to see any files or exercises to do with this tutorial. And with that, I think it's time to hand over to Sven, who will take over from Annie. So let's get started. So let's have a look at what sets are, what they're not, and how you might use them. So here's some examples of sets. This is a set of all the prime numbers less than 10. This is a set of all the characters from Friends, who we'll meet again shortly. And this is a set of all the famous ex-Preston North End football managers, but I don't think you needed me to tell you that. So what sets don't have is two main things. They don't have duplicate values, and that turns out to be quite useful. And also, they don't have any concept whatsoever of ordering. So how would you use them? Well, there's a couple of main ways. One is for removing duplicates from a list, and the other is for comparing two lists. So what we're going to do now is have a look at how you can create sets, and then we'll have a look at some practical examples. So before we look at how you can actually use sets in practice, let's have a quick look at some set theory. Apologies if this takes you back to unpleasant memories of school day maths. So let's imagine you have two sets. You have a set of the people or the characters who have appeared in Friends, the TV series, and you have a set of Antarctic ice shelves. You might think they don't have a great deal in common, but you'll be wrong. If you look at this diagram, it shows that there's an intersection between the two, which is occupied by Ross, so that's a non-empty set. On the left-hand side, you can see a list of all the characters who are in the Friends TV series, but who aren't ice shelves. And then on the right-hand side, and I think you've probably got the point by now, you can see ice shelves, which aren't Friends characters. This is called, as you probably know already, a Venn diagram, and it's a useful way of understanding how sets work. What we're now going to do is have a look at how this works in Python as well as in maths. Don't worry about this scary diagram. I'm just putting it up for reference. When we do the practical examples, you'll barely need to know about it, but some people will find it useful. So the main concept in set theory, or main two concepts in set theory, are intersection and union. So the intersection of two sets is the thing they have in common. And that's written in mathematics as A intersection B, and in Python as A ampersand B. It's that simple. The other key concept is the union. And the union of two sets is the elements which are in both sets and in the intersection. So that's everything. And that's written in Python with a pipe symbol, which you'll find at the bottom left of your keyboard. And then there's two more complicated concepts called the complement and the elements which are in one set and not in both, which you probably won't need most of the time. So that's all the background theory for sets. It's time to start creating some. What we're going to do now is to create a couple of sets. I've created a file called workingwithsets.py. And to create a set, let's have a set of all the friends. You type in the name of your variable, which is going to refer to it, which I'm going to call friends. And then you type in not a round bracket, not a square bracket, but a curly bracket. And that denotes either a set or, as we'll see, probably in the next tutorial, it can also denote a dictionary. So what I'm going to do is paste in my list of friends. If you're wondering how I did this little bit of magic with the multiple clipboard, try, if you're running Windows, try holding down the Windows key and pressing V. It's amazing how much time it saves. So I'll just tidy that up. You don't need to put this on multiple lines as I've done there. but it probably makes it easier to read. Normally you'd have to use a continuation character like a backslash, but for some reason Python is quite forgiving when you have items in a list or a set or tuple or whatever it may be. So my second set is going to be the Antarctic ice shelves, which I will call shelves. And I'll set that equal to, and again I can press Windows V, although it was in my immediate clipboard, and I can bring in the list of selected Antarctic ice shelves. And hopefully if you're watching this in about 10-20 years time, they're all still there, but we shall see. So having created a set, I could then print them out. So to print out a set, it's exactly the same as anything else. I could print out the friends, and I could print out the shelves. And if I now run that program, you'll see it just duplicates or echoes back to me what I've just typed in. What I can also do is prove what type they are. So I'm going to prove these as sets. And to do that, I can use the ever useful type function. So I'll print out the type of the friends and the type of the shelves, just to prove to you that I'm working with sets and not something else. But you probably believed me at this point. So that's how you can create sets. Now we're going to look at some operations you can perform upon them. So before I show you some set operations, let's quickly comment these lines of code out. And then what we're going to do is start by showing the union between the two sets. So the union is in everything in both sets. So to do this, I will create a variable called union, and I'll set it equal to the friends, also the shelves. And what I could then do is print that out. And what you'll see is when you run that, it gives me characters or ice shelves. The important thing about this is Ross only appears once, even though he's in both sets. I've told you already that a set cannot contain a duplicate, and so any duplicates will be stripped out. So that's one example. So the next thing we'll do is we'll show the intersection. So these are things which are in one set but not the other. So to do this, I'll create my variable called intersection. You don't have to call them names like this, you could call them anything you like. And I'll take the friends, and to get the intersection, I use the ampersand. But I think that's quite logical. They've got to be in both the two sets. And again, I'll print that out. And what you should see when you run this is it gives you just Ross, because Ross is the only person, or I shouldn't call him a person, the only thing which is in both the two sets. Those are the two basic things that you'll normally want to do. Let's now show all the ice shelves which aren't friends. There should be two of them. I can't actually remember the name, I'll be honest. So let's create a variable called ice shelves not friends, which kind of makes the comment redundant, but never mind. So to do this, I'll take the list of shelves and I'll subtract from it the friends. And as always, it's just so nice and logical and exactly the way you'd have wanted it to be written. So I can print out my variable called ice shelves not friends. And I should get McMurdo and Ronnie Filchner. How could I forget that? Those are the two elements which are in one set but not in the other. And of course I could have done it the other way around to get all the friends who weren't ice shelves. And the final thing I was going to show you is elements in either set, or both. So to do this, I will create my final set, and because I'm running out of long names, I think I'll just call this Bob. And I will set this to be the elements which are in the friends. And the symbol I'm going to use to get this to work is it's actually called a caret. It's written, and if I now print out Bob, you should see when I run that it gives me as a final element every single item in both lists apart from Ross, because he was in both of them. So those are the main things you can do with sets. And what we're now going to do is look at some practical examples of 3 practical examples of how you can actually use sets. So for the first example, what we're going to do is I'm going to read in my shopping list and remove any duplicates from it. So you've got a file called shoppinglist.txt attached as one of the files for this tutorial, and it contains duplicates. Because as I get older, I forget whether I've written something down, and I tend to have the same thing written down 4 or 5 times. And so what I want is a little Python program which will read down these items, remove all the duplicates, and then present my list back to me in sorted order for convenient shopping. So you can see where we're going with this. Here's what the answer should look like. I'll firstly read in the initial list. I'll strip out any duplicates, and then finally I'll sort it. And to do this, I'll need to turn it to a list, then back to a set, and then to a list. And it's all very elegant and a really nice solution to the problem. So I've created a file called eg1removeduplicates.py. It's a great name. And what I'm going to do is to create an empty list to hold my items of shopping. So I'll call this items. And I can use 2 square brackets, one after the other, to create an empty list. What I'll now do is read in the file. So to do this, I can say with open. I can put the name of the file in quotation marks. It's called shopping list.txt, and I'll call that shop file. So what I can now do is read in the lines. To do this, I can say for line in shop file. All of this we covered in a previous tutorial on working with files and folders. So for each line, I now want to add it to my list. So to do this, I can say items, and then I can append the item. Also extend it actually, and I'm going to put line.strip. The dot strip is because I want to remove any trailing new line character which I know I'd otherwise get. So my end result of running this should be my first output, which is my unadulterated list. What I'll do is print out the initial list. I'll type in the words initial list, and then what I'm going to do is left justify that with 20 characters and add on to that the list itself. Now to display the list itself, I'm going to use what I think is probably a new function for this tutorial, repr. And what it'll do is produce a string representation of the list, which is slightly more reliable than just using str. So the string representation of my items list should just, well, let's find out. If I try running that program, you can see it gives me my initial list. There's no sorting and there's no removing of duplicates. So that's a good start. So what I'm now going to do is I'm going to remove the duplicates. And this is ridiculously easy to do using sets. So I'll create a variable called item set. And what I'll do is I'll just convert my list called items to a set. And the act of doing that will remove any ordering, but also remove any duplicates too. So what I can then do is I could just print that out immediately afterwards using a bit of cheating here to copy my code. I'll call this revised list. And this will print out the string representation of my set. So now if I try running that, you can see my revised list is the same, except that it removes any items. It turns out I typed bread in twice, and I think I typed apples in twice as well. So my list has gone down from the initial 9 items to only 7. It's a fantastically easy way to remove duplicates. But the problem is I now want to sort that, and I can't sort a set. So what I'm now going to have to do is to sort this as a list. And to do that, I need to create another variable, which I'll call items2. And this will take my set and turn it back into a list. And then I can sort this using the standard method of sorting for a list. And finally, what I'm going to do, excuse me, is print out my final adjusted list. To put a 2 in there. And when I run that, you can see my final list is sorted into alphabetical order. So by keeping moving things from a list to a set and then back to a list again, you can do very powerful things very quickly. So for my second example, what I want to do is count how many letters and words there are in a string of text, but also how many unique letters and unique words there are. So to do this, I'll create a variable called quotation and set it equal to this. It's a quotation from The Day of the Triffids by John Wyndham, one of my favourite books, and we danced on the brink of an unknown future to an echo from a vanished past. Now, the first thing I'm going to do, I must admit, is a bit of a red herring, but some people might find it useful. What I want to do is strip out any punctuation from that first. It'd be relatively easy for this because I've only got commas and full stops, but you might have more complicated characters as well. Now, one way to do this is with something called a regular expression. I'm no expert on them, so I'm going to use something called a translation table. And this is very much an extra. Think of it as a bonus if you like. So to do this, I'm going to create a variable called table for translation table. And I'm going to set it equal to str.maketrans. And this is one thing I am not going to attempt to explain. I'm just going to get it working. Now what I want to do is refer to a string of all the punctuation characters. And a handy way to do that is to import a module called string. And then I can type in string.punctuation. If you're not sure what this is referring to, remember always that you can right-click on that and choose Go to Definition or press F12, and you'll actually see all the punctuation characters, and there's loads of other useful strings in there as well. So going back to my previous text, what I can then do is use this translation table to strip out any punctuation characters from my quotation. And to do that, I'll create a variable called clean quote, and I'll set it equal to this. So I'll take my initial quotation, I will translate it using my translation table. So although the syntax doesn't particularly lend itself to be easy to the eye, I think you can see what this is probably doing. And just in case you can't, let's have a comment to remind your future self. So if I now try printing out that clean quote, you'll see I get the same thing, but without any punctuation in. Good. Now we can do the proper example. So to get the number of letters in, I could just use the length of the text. So I can say print number of letters equals concatenated with, and what I'll have to do is convert the length of the quote to a string to get this to work. When I run that, you'll see it says there's 79 letters in that. I guess about what you'd have guessed. Now to convert this to a set so that we can strip out the unique values and count how many unique letters there are, we need to create a variable. So let's call it a letter set. What we can do is take the clean quote and convert it to a set. The reason this will work is remember that Python always considers a string of text to be a list of the individual characters. So this will convert it to a set of all the individual characters. If you don't believe me, you could always try printing this out, and you'll see it gives me the list of the individual characters with all the duplicates removed. So all I now need to do, as I comment that out, is count how many unique characters there are. So I can just copy this line above. A change to it, so number of unique letters equals. And what I can then do is instead of counting the characters in clean quote, I can count it in letter set. And when you run that, you'll see there's only 21 unique letters. So the quotation uses, out of the 26 letters of the alphabet, it uses 21 of them, which isn't bad going, I think. So that's how you can count letters. To count words, what I'm going to do now is to create an array which splits my quotation up with different spaces. So to do this, I'll create an array called words. I will take my clean quotation and I'll split it by the space character, like so. And you'll notice I always keep printing things out. The reason I do that is because it's a good way of testing you're going in the right direction. So if I print that out, you can see I get my words. How many words are there? Well, I can find out by saying the number of words equals, and then I can concatenate onto that the length of the words list. And if I run that, you'll see it says there's 17 words. But how many of them are unique? Find that out, I can do the same thing that I've done before. I can create a variable called word set, which will convert my list of words into a set. And of course, the act of doing that will remove any duplicates. So what I can then do is print out the number of unique words equals, I've lost my format function. I don't know why I'm doing this the long way around. The length of my set. That out. You can see there were 16 unique words, and that must mean one of them is repeated. And at a glance, I think it's the word "an," which appears twice. To get this to work perfectly, I should really have converted my words to lower or uppercase, because the word "and" with a capital A will not be treated as the word "and" with a lowercase a, but fortunately I haven't got any other occurrences of the word "and." So that's my second example. So for the third and final example on working with sets, I'm going to show you how to find all the football teams who were relegated or promoted at the end of the 2021 football season. So I've got two files. I've got the Premier League 20 to 21.txt, and that contains the teams as they were last year at the time of speaking. And then I've got the teams as they are this year at the time of speaking. And there must be some discrepancies between the two, and that's what I want to find. And the solution to this, I think, is one of the most elegant Python programs you can write, but see if you agree. So I've created a file called eg3 promotions and relegations.py. And what I'm going to do is read the two files in first. So let's have a comment to that effect. So for the first one, I can say with open, and I can put the name of the file. So I've got the path there, and I've got the text of the file there. And I'll call that PL1 file. And then to read that into a list of all the lines, I'm going to create a variable called PL1 teams and set that equal to PL1 file. Read in absolutely everything in that file and split everything into different lines. So that will give me a list containing a list of all the teams. And then I can do exactly the same thing a second time. And the only difference for this is I need to replace 1 with 2. And I was about to do it with a global replace. I've realized that might not actually be a good strategy because there's more ones than I thought there were. So I think I'll have to manually go in and change that. And of course, change the name of the file too to 21-22. So as always, I'm going to test this out before I do anything else. So I'll print out my first variable and indeed my second variable. And let's see if it's actually working. So if I run that, you can see I get my two lists of teams. Quite what's happened to Arsenal there, I don't know. There seems to be a strange character at the beginning of my file. So I can now get rid of those two because I know that's working. And the next thing I'm going to do is I want to compare the two to see what the discrepancies are. And the neat way to do that is by converting them to sets so that I can do that. So I convert the list to sets, and I'll call the first one PL1 set and use the set function to take my list of teams and convert it to a set. And as always, there's a bit of repetition involved here because I can now do the same thing for the next one. So I'm hoping I've got two sets containing a list of all the teams. And then I can see the discrepancies between the two. And to do that, I just need to take one set minus the other. So I'm going to create a variable called relegations. Let me see if I can get this right. The relegations are the people who in the list of teams in 2021, but then vanished from it in 2022. Likewise, the promotions are people who did the opposite. They were in there in the second season, but they weren't in there in the first. It's just such a beautifully elegant way to solve the problem. So now I can print those two things out. So let's start with the relegations, being a natural pessimist. So I can take that and I use the REP function, which I used earlier, to show the list of relegations. I think I could have got away with a string function. It would work fine, actually. And then I'll print out the promotions. And rather than using any complicated justification function, I'm just going to add in an extra space in there. Mickey Mouse programming. And I'll show the promotions. And that's it. 8 lines of code to print out the relegations and promotions. And what I'm going to now do is try running that. And you can see that West Bromwich Albion, Sheffield United and Fulham went down. And Norwich, Watford and Brentford went up. And at the time of writing, Norwich are struggling quite a lot, but Brentford, I think, at the time of speaking, are in the top four. So that's good news for all Brentford fans.